We have entered the golden age of space exploration. A unique new space telescope has begun to observe depths of the universe that we could never have imagined. With every observation, the James Webb Space Telescope reveals the oldest galaxies in the universe, stars we cannot see, and traces of new worlds. This is more than just a space telescope. It is a time machine that is rewriting the story of the universe by uncovering the secrets of billions of light years away. On 25th December 2021, while everyone around the world was celebrating Christmas, a historic journey beyond our planet began. From a launch pad in French Guiana, the Ariane 5 rocket launched a highly sensitive and valuable payload into the depths of space. A payload whose design, construction, and preparation had taken decades. This payload was the James Webb Space Telescope, the most powerful observatory ever sent into space. Its destination was the Lagrange 2 point, which tracks Earth's movement around the Sun and is located directly opposite the side of Earth facing the Sun. The reason for choosing this point is that it will block the heat from the Sun, keep the telescope cool, and allow the JWST to continue its observations while consuming less fuel. The Lagrange 2 point, located 1.5 million kilometers from Earth, provides an ideal environment for the James Webb Telescope to see what is invisible in the depths of space. Thus, JWST will continue its observations much further than the Hubble Space Telescope. While Hubble can observe visible and ultraviolet light, James Webb is capable of seeing infrared light. Thanks to this ability to see infrared light, James Webb can reveal newly forming stars trapped in cosmic dust, the oldest galaxies in the universe, and even the contents of the atmospheres of distant exoplanets. The James Webb Space Telescope is a 6.5-meter wide telescope with a total of 18 mirrors. Its mirrors, which open like the petals of a flower, have 6 times the light-gathering capacity of Hubble. Thus, the James Webb Space Telescope not only sees stars, but also observes the early universe, allowing it to look back in time. The mission of the JWST is literally cosmic archaeology. To see the first light after the Big Bang, to discover the origins of the first stars and galaxies, and to search for signs of life on distant exoplanets. The James Webb Space Telescope is not just an observational tool, it is also a golden symbol of humanity's courage to explore the depths of space, driven by our curiosity. Now, let's take a closer look at the awe-inspiring discoveries made by James Webb. The most significant contribution of the James Webb Space Telescope is not only to discover distant galaxies, but also to thoroughly examine the light coming from distant exoplanets. This gives us the ability to analyze the atmospheres of planets orbiting stars hundreds of light years away in much greater detail. James Webb clearly detected the presence of water vapor on a giant gas planet called WASP 96b. Of course, this is not liquid water, but only water vapor in the thick, hot atmosphere of the planet, which orbits its star in just a few days. This planet orbits its star so closely and so quickly that there is almost no chance of the water in it being liquid. Another groundbreaking discovery made on exoplanets was the detection of carbon dioxide on the planet WASP 39b. This was the first discovery of carbon dioxide in the atmosphere of an exoplanet. The reason it is groundbreaking is both because it was the first discovery and because carbon dioxide is a fundamental building block of organic molecules that enable life to form. These discoveries have enabled us to determine for the first time what the atmospheres of distant worlds are made of. Webb has also paved the way for a new field of study with each molecule it discovers: comparative planetary science. And with each exoplanet we study, we get one step closer to discovering the conditions necessary to support life. We are closer than ever to uncovering other worlds with characteristics identical to our own. Perhaps the most awe-inspiring achievement of the James Webb Space Telescope is its ability to see further and earlier into the universe than ever before. Thanks to its powerful infrared vision, James Webb has managed to capture light that has been traveling for just over 13 billion years. This light, coming from the early infancy of the universe, gives us striking clues about the first galaxies. One of the most groundbreaking discoveries was SEER 93316 galaxy, which began to shine just 300 million years after the Big Bang. Images of this early period of the universe had never been observed so clearly before the James Webb. After the discovery of this galaxy, an even older galaxy was discovered. The galaxy, named Galaxy 12, is thought to have formed just 250 million years after the beginning of the universe. These shocking galaxies appear brighter, larger, and better formed than scientists had anticipated. Our understanding of how quickly these cosmic structures could emerge in the period immediately following the Big Bang is beginning to undergo a fundamental transformation. The James Webb Space Telescope does more than just photograph distant galaxies. It reveals the era when the first stars began to shine, galaxies began to form, and the cosmos began to take shape. With every light it captures, the story of the origins of everything is being rewritten. One of the most breathtaking features of the James Webb Space Telescope is that it is advanced enough to witness the birth of stars. Thanks to its infrared vision capability, James Webb can see dark areas of space that ordinary telescopes cannot see. As a result, JWST can penetrate dark regions of gas and dust clouds to closely examine the moment a star is born. In one of Webb's first images, the Carina Nebula, regions where thousands of stars are born, have emerged in a way never seen before. The massive gas columns, shaped by radiation and stellar winds, appear to form mountain ranges. These gas regions can be described as the birthplaces of new stars. The Pillars of Creation, one of Hubble's most famous targets, was re-photographed by JWST. These new images have revealed details that have remained hidden for decades. The James Webb Telescope allows us to observe the entire cycle of a star, from its birth to its death, in greater detail, from collapsing gas clouds to the birth of new suns, to nebulae shaped by stellar winds. These nebulae are not only awe-inspiring for their breathtaking beauty, but also for the secrets they hold, because being able to see into the depths of these nebulae allows us to understand how stars are born, the active structures of galaxies, the formation of planets, and even the origin of the atoms within us. Deep in space, 5 galaxies have been spinning, merging and colliding for millions of years. We could say that they are performing a truly intergalactic dance. This group of galaxies, known as the Stephan Quintet, was discovered over a century ago, but it has never been seen like this before. Thanks to the JWST, we now have the most detailed and high-resolution image of this galactic dance to date. The gas, dust, and stellar streams between the galaxies appear to form a cosmic bridge. These galaxies are tearing stars from one another, and the chaos of the collision triggers the formation of new stars. Thanks to Webb's sensitive infrared vision, the intensity and heat of these intergalactic interactions have been revealed. This magnificent image obtained by Webb has enabled us to study in detail the evolution, formation, renewal, and intergalactic dust and gas cloud sharing of galaxies. What you see in these images is not the destruction of galaxies, but their transformation. Galaxies merge, their stars intermingle, and collisions trigger new star births, a process that has shaped our universe for billions of years. By closely examining these galaxy collisions, we can predict the outcomes of the future merger between our Milky Way galaxy and Andromeda. This image stands before us like a portrait of cosmic evolution, showing us how galaxies grow, how new star formations are triggered, and how the universe endlessly recreates itself. One of the first images from the James Webb Space Telescope showed a view of the cosmos that was wider than anything we had ever seen before. In this image, thousands of galaxies can be seen together in a single frame. This collection of galaxies, each containing hundreds of billions of stars, stretches into the depths of space and time. The small points of light that appear in the image are not stars, but the oldest galaxies in our universe. Some of them are so far away that their colors have shifted significantly towards red due to the expansion of the universe, and it has taken over 13 billion years for their light to reach us. However, if you look closely at this image, you will notice a much more striking detail. The massive galaxy cluster in the foreground has created such a dense gravitational field that it has caused what we call a gravitational lensing effect in space. This has bent the light from even more distant galaxies hidden behind it, making them visible to us. This phenomenon allows the JWST to see invisible galaxies and reveal the oldest structures in the universe. It is, in a sense, like looking into the depths of the universe with a natural and massive telescope. These deep-field images are like maps showing the structure of the universe. They vividly reveal how galaxies come together to form clusters and networks, and how matter is distributed throughout the universe. Webb helps us understand the cosmos' fascinating structure and our place in the universe through every pixel in its images. In its first year, the Webb telescope has already begun to reshape the foundations of cosmology with its striking discoveries, hinting that the universe may still be filled with secrets waiting to be uncovered. JWST has undoubtedly made many breathtaking discoveries so far. However, it seems that more new and striking discoveries will continue to be made. Webb will continue to discover exoplanets located in habitable zones around other stars. It will conduct in-depth research into the atmospheres of these planets, searching for signs of water, carbon dioxide, and organic compounds that are essential for life. Additionally, Webb will examine the atmospheres of closer targets like Titan, revealing their mysterious surfaces in unprecedented detail. Of course, JWST will continue its deep space research. It will help us better understand the first supernovae, the formation of black holes, and the structure of dark energy and dark matter, the mysterious forces that shape the cosmos. The James Webb Space Telescope will not be alone in this adventure. Working in coordination with Hubble, ALMA, and ground-based observatories, it will form a powerful network that enables us to explore the universe in depth. With JWST, a new door to discovery has been opened, and it seems we have entered a golden age of cosmic exploration. Every discovery helps us better understand our place in the universe. We are entering an era where science fiction is becoming a scientific reality. If these initial discoveries by the JWST are just the beginning, we can only imagine what will be uncovered in the coming years. Subscribe to our channel for more space videos and documentaries, like our video, and click the notification bell to stay updated on our latest videos. See you in our next video.